Hi everyone. I'm back with another live stream. I'm a little late, maybe 8 minutes late, but sorry. But finally I'm back. I was thinking of that my hair gets dry and then I can start, but it's not. So I've started. So eventually it will be. But let's focus. So today, most probably we'll be going through few revisions of what we prepared for the MAANG interviews, and and then we'll be picking up a few questions based on based on Google sorted. So I already have taken a premium for lead code, and I'll be solving questions of premium questions which are being asked in Google. So if you are preparing for any of these interviews like Microsoft, Google, Amazon, or anything like that, you can come here. You can join my stream. We'll together solve the questions and we'll grow together, something like that. So it will be a really interesting thing to use our brains in the morning only, starting morning using brain and then ending a day with a full satisfaction that yeah, I did a good uh, amount of questions. I solved a good amount of questions and I'm happy. So yeah, for that, uh, on that note, I'll start today's uh, DSA live stream. So usually it'll be same, very same mm, as I do in past. It'll be 50 minutes of coding, and then we'll take 10 minutes of short break. Let me open. So it'll be something like that. So we'll start by today's coding. Maybe today we'll go through some of the older revisions that I've already done. So for the graph questions, because it's been 5 days, I haven't seen those questions. And what happens generally in interviews, we need those questions in back of our mind. So if we are not prepared to that level, that we can store questions at the back of our mind, or even the concepts, the algorithms at the back of our mind, we won't be able to qualify those exams. So those interviews. So we need to have those things at the back of our mind. So for that, I'll be going through the graph related things again. So I've already created a list. This is my list. If you want, you can check this out. I'll paste it in the chat. So this is where I created, very much relatable to the lead coding, where I think Fraz created. And what I did is I filtered which were not very much required for us, even though he solved lots of questions which were not required. So I thought of removing those and keeping it concise, whatever we want, uh, whatever questions is looks like more relatable to an interview level. I stored it that and filtered the rest of the things. So for the graph is really long. So for graph, I have BFS, I have DFS, I have detect cycle algorithm, graph representation. That is the first thing. Then shortest path, and then topological sort. So just a second. Okay, so we have lots of things over here. We can start with any of the one at first, and then we can slowly grow together. So searching algorithm, I have a KMP algorithm. So we know we have binary search, right? So binary search is very trivial. The algorithm is very trivial, but the KMP algorithm, it's really good to understand how KMP algorithm works and what we are doing in KMP algorithm and how KMP algorithm helps us to find anything in O of n time and not going for O of n square time. So something like that. So KMP algorithm is really good. So I added that, and these two questions are based on KMP algorithm only. So it's really good. The searching algorithm is really good. For binary search, I'll also go for binary search approach. We have few questions related to binary search which are really good. The one question that comes in my mind always when I think about binary search is cocoa eating banana. So that question is really amazing. So it'll give you a nice concept. Okay, so let's start with why not BFS? So let's start with our graph representation, and then we can go for BFS, then DFS, then detecting cycle, then shortest path, then topological, and something like that. So we have our graph representation in two parts. Let me start my timer. So we will be seeing the graph representation in two way. First is matrix way, and the second is list way. So if we see our matrix way, it's nothing. It will say that we need to store the edges in a matrix format. So what this matrix format says is uh, we have a matrix. We'll create a 2D matrix of size n cross n. 1 2 3 4 5 6 1 2 3 4 5 and 6. Okay, so we have total of 6. Suppose 6 n is equals to 6. Okay, obviously we have 6. So there are total of 6 edges. These are the edges. So what we need to do, will simply iterate over these edges, and wherever these edges will say, I'll mark it as 1. So 0 3 0 to 3, I'll mark this as 1. Rest of the part will be 0, initialized with 0, and wherever we have an edge 0 to 3, there is an edge, so I'll mark it as 1. 1 to 2, there is an edge between 1 to 2, so we'll mark it as 1 to 2. 1 1 to 5, there is an edge between 1 and 5, we'll mark this as 1. 2 to 4, we have an edge between 2 to 4, we'll mark this as 1. 3 to 5, we have an edge from 3 to 5, we mark this as 1. 5 to 4, we have an edge from 5 to 4, we mark this as 1. And 5 to O, so we're back to initial point, so we mark this as 1. So this is how we generally do our matrix representation of a graph, and rest of the values will be simply 0 0 0. So correct, it's very long. Come on, complete fast. Yeah, so this is how we create our matrix. Now if we have to iterate, and if we have to check where there is an edge from is there any edge from 0 to any other node. So you can see the 0 is, there is an edge to 3, from 0 to 3. From 1 is there, how many edges are there? So from 0 we can connect 3. It may be directed, it may not be directed. That doesn't matter. So 0 to 3, That depends on question, if whether we are given with a directed graph or undirected graph, so it doesn't matter. From 1 to we can go to 2. We don't have 1 to 2, fine. From 1 to 5, again we can go from 1 to 5. From 2 we can go to 4. From 2 we can go to 4. From 3 we can go to 5. From 3 we can go to 5. So it's how something like this. From 4 I can go nowhere. Okay, 4 is done. From 5 I can go back to 0. So it's kind of a messy graph, but this is how the graph will look like. So this is the matrix representation. It's not that difficult. It's fine. It's easy. Now let's jump to our list representation. Let me remove this. So our list representation is better than our matrix representation. Why? I'll tell you at the end. But how list representation works is we have given edges. Now we need to connect those edges. So we have n is equals to 3. Let's take the previous example only. This example, list of maybe I'll show you here. So we have 6 edges. So what we'll do, we'll create a 2D matrix of size 6 initially. I'm saying I'll create a size of 6, not 6 cross 6. So I'm creating only one size. We can give row. We cannot. We may give column. We may not give column. So depending on the type of graph, it will form automatically. So 0 is connected with 3. I'll directly push 3 over here. 1 is connected with 2. 1 is connected with 5. I'll push 5 again. 2 is connected with 4. 3 is connected with 5. 5 is connected with 4. And also 5 is connected with 0. So there is no 6 here. So there, this is how the edge will look like. The list representation of this. So this is how we do. So most in general it will be undirected. So if we have 0 to 3 edge, then we have 3 to 0 also. So it will be something like that. 3 to 0 also there is an edge. If we have 1 to 2, then 2 to 1 also. 1 to 5, then 5 to 1 also. Because it's an undirected. If it is an undirected, if it is directed, we only have to push one side and not both from both sides. So this is how a list representation works. It is efficient than matrix representation because it takes less space. It takes less time to iterate and find the corresponding neighboring edges of one node. So it's obviously way better than any other approaches. So this is what our list and matrix representation is. So it's kind of easy. It's not that difficult. Let's jump to our BFS, breadth first search part. So now for the breadth first search, we have something. We have some kind of graph. Let's suppose we have a kind of the graph is 1 to 2 3 4 5 6 7 8 9 10 and 11. So this is a kind of graph. Now breadth first search will tell me what? It will tell me how to search any specific node from any specific node. Means if we want to go from one to any other node, like suppose 5, so what is the efficient way to search from a source? If this is our source node, we consider this as our source node and this is our destination node. So what is the shortest path from where I can reach from source to destination? If has one thing, if all the edges has equal amount of distance, so if the edges has equal amount of distance, we can directly apply our breadth first search to start from source and to end to destination. Okay, so it's kind of searching in a graph or iterating over a graph, and using BFS we need a start node from any of the start node. We can start with any of the node. It does not mean that we have to start from one only. We can start from any of the node and we will start iterating over exploring all the neighbors from one position to all others. So from 9, if I see, I'll explore all the neighbors from 9. So from 9, if I see, I can explore 4, I can explore 11, I can explore 10. So this is how our queue will start. We'll have a queue. So inside this queue we have suppose our source is 1 only. So from 1, how many neighboring can we go? We'll pull this one out. We'll go to their neighbors. From 1 I can go to 2, from 1 I can go to 3. So 2 and 3 will be pushed into our queue and 1 will be popped. 1 after popping we can push it in my resultant array or anything. That's fine. We'll pick 2, we'll pop it, we'll push it, and after 2 which neighbors can I go? So from 2 I can go to 6 and even I can go to 1, but I will not go to 1 because it's already visited. I've already visited that array, so I'll mark it in our visited array that okay, this array has been visited. I do not have to go to that node again. So from 2 I can go to 6. So 6 will be pushed in my queue, and then it comes 3. So from 3 I can go to 4 and 5. 4 and 5 we cannot go back to 1 because it's already visited. From 6, now 6, from 6 I can go to 7. We cannot go to 2, already visited. So 7, from 4 I can go to 9, and that's it. From 5, now from 5 I can go to 8. From 7 I can even go to 8. See, but 8 it's already in my queue, that it's possible that why we will add it again. It's if it is already in my queue, so I have already marked it, so we don't have to go to 8, push 8 again. So from 7 I should not go to anywhere. I have already visited 6, I have already visited 8. From 9 I can go to 10 and 11. From 8 I can go to nowhere. From 8 5 already visited, 7 already visited, so nowhere. From 10 nowhere. From 11 nowhere. So it's fine. So this is our BFS will work, and this is what it will give me the resultant. 1 2 3 6 4 5 7 9 8 10 11. it depends which source node we started with, so it might vary. So depends on our source node from wherever we are starting. So the coding part is very simple. We have a queue, we have a visited array. We'll start pushing with a source node, and we'll mark that in our visited that it's already visited. Now we'll pop the first node from the queue. I'll put it in my resultant. I'll pop it from the queue. I'll start exploring its neighbor. If its neighbor is not visited, if it's 0, then I'll mark it as visited and push it in queue. So it's very simple, the normal BFS. Now comes the multi-source BFS. Multi-source BFS is something from multiple source we are going to multiple source. So for example, if we have rotten oranges, so rotten oranges is something multi-source BFS, because we have multiple sources. We do not have only one source where we can start. We can start from any of the sources. Okay. So this is a question that I solved based on multiple sources, is shortest path visiting all nodes. So if I open this question, I'll tell you how this will work. So let's take this as an example. Uh, so in this, the question is, I can start from anywhere. The question is, I need to visit all the nodes, and in that duration, if I'm visiting all the node, I can start from anywhere. It doesn't matter from where we are starting. We need to visit all the nodes, but in minimum steps. This is what this question is saying: minimum steps. So if I can see from the first example, if if we start from 1, it's something from 1 I can go to 0. From 0 I go to 2. From 2 I can even go back to 0 again. It's saying that we can revisit the same edge again, but there is a trick. From 1 to 0 I am visiting, from 0 to 2 I am visiting, from 2 to 0 I am visiting, from 0 to 2 if I again visit, can I visit? So it's something based on configuration. I'll tell you. I'll tell you how this work. So we need to have some kind of configuration beforehand. Then only we will be able to solve this. Now I'll tell you something, some kind of configuration that we can create over here. So suppose we are taking a good path only for now. We are not going for any kind of bad path for now, just for example. So from 1 I started, so we have 1 as our node, and we will have the cost, which is 0 obviously. So we have node, we have uh, cost, and we have something called mask. What are these three things? I'll tell you. So this is our my first node, this is my cost as 0, and this is my mask. Mask is nothing but telling me that I have visited 1. So there are total of 12 nodes that we can have. So we can create a mask by using bit masking. Bit masking will do what? Suppose this is a number 1 2 3 4 5 6 7 8 9 10 11 and 12. This is a total of 12 zeros, and masking 1 will tell me that I have visited node 1, and a mask is 1. That means masking, always in bit manipulation, everything starts from right end. So if we consider, just for now, this is our 0th node, this is our first node, second node, third node, fourth, fifth, sixth, seventh, 8, 9, 10 and 11. So at every position will have a different mask value. So if I have visited 1, I can say that I can change this to 1, that I have visited this. Now what will happen is the mask will be something like 0 1, and rest of the things will be 0 0 0 0 dot dot dot. This is my mask, first mask. Now from 1 I went to 0. So from 1 I popped this. This is something in our kept in our queue. I have 1. I popped this out. So my new node is 1. Its cost is 0. Its mask is something like 1 0 0 dot dot dot, something like this. I popped this out. I explode its neighbor, which is 0. I'll check whether I have visited that node with the same mask or not. You will get it. Eventually you will get it. Just be with me. So I have node 0. I am going to node 0. So the new mask that will be created will tell me that I have already visited 1. I'm going to 0. That means I'm creating a new mask with 0 as 1 also. So this is my new mask. So I visited 0 with a cost of maybe 1, because each step takes 1 cost. So cost is whatever we had cost earlier plus 1 to the new cost, and our new mask is something 1 1 0 0 0 dot dot dot. So this is what our new mask is. Now let's try from 0 where all I can go. I have this node 0. Now for 1 it's done. I have node 0. I have a cost of 1. I have mask as 11000. Now from this node I can revisit node 2, I can revisit node 1 also. Let's suppose I go and revisit 1. So I'll keep somewhere these visited one, because I don't want to revisit with the same node and the same configuration again. So what I'll do, I'll keep node 1 with a mask of 10000 dot 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 somewhere in a set that I have visited one with the configuration of this node and mask, right? So from 0, if I go back to 1 again, now here's one thing that you need to know. From 0 I'm going back to 1 again. Now earlier in BFS, normal BFS, what happens was I visited 1, I went from 1 to 0. Now from 0, if I go back to 1, I'm pretty much sure that I will not visit that one again, because I have already visited that one. But here the case is different. I can revisit one because the configuration that we have is different. Will tell you. Now I popped this queue from the queue. I'll store it somewhere 0, node 0 with a mask of 00011. Correct. And if from 0 I can go back to 1 again, from if I'm going to 1 again, right, so if I'm going back to 1 again, what are the things that will change? From node 0 I'm going back to node 1 again, and in 1 I have already this mask 1 set to 1. That means I have already visited that mask. So my new mask will remain same 00011. But can we find this in our set? See, did we visit 1 with the same configuration again? No. From 1 I visited to 0, and from 0 I am visiting to 1 again. So the configuration from 0 to 1 changed. So this is what I was telling you. So 1 with a newer configuration is there. So I can push again 1 with a cost of 2, whatever cost we had earlier for 0, and the newer configuration. So this is what newer configuration. Now here comes what I was telling you, how to stop these recursions from same place to same place again. Now let's look once more to the same configuration, to the same thing. I popped this out, 1 with cost of 2 and 00011. It's the mask. From 1 I can go back to 0 again, right? From 1 I can go back to 0 again. Now going back to 0, will it change the configuration? 0 is already visited, so the newer mask will be this, and node 0. Is it present in my set? Yes, it is. 0 with the same configuration I have there in my mask. That means from 1 to 0, if I'm going from 1 to 0, my mask changed. From 0 to 1, my mask again changed. From 1 to 0 again, if we are going, our mask remained same. So this is where the repetitive thing comes. So we need to stop those repetitive. Hello, artsful art. How are you? So we need to stop this repetitive things again and again. Hey, why you deleted? So this is what this question says. Now, now it becomes very simple. Now the question becomes very simple. We have three things: node, cost, and mask. A tuple, a class created for that. Now we do what we already have been given a graph. We don't have to create a graph. We created a queue of tuple, and for every node I'm creating a mask. This node, this mask with a cost of 0, I'm pushing everything in my queue because I don't know from where I will start. I'll get a result. Yes, I know you. Artsful art. You are either Tanu or Anirudh. Aradhya or Anirudh. So, what I was doing, I did this. Now, this is my all mask. All mask is something, uh, all the nodes are visited. So, 0, 1, 2, 3. If all the nodes are visited, the all mask will be every node correct. As I created a set of for visited, I'll create keep node and the corresponding configuration over here. Now I'll pop the first from the queue. I'll pop that out. I'll check its mask, whether its mask is coinciding with my all mask. I'll return this cost. Hello, hello Lalita Devi. From whose account are you all coming from? Hey, do like my channel, huh? Do like, share, and subscribe. Oh, you exam. That means you are Tanu. I do have my exam, so I'm preparing for that. Tuesday को maths है. Yeah. So today is Saturday. We'll meet in the evening. Study with me live here till evening, and then whatever doubt you'll have, we'll connect back in the evening and we'll clarify that doubts. Right? Yeah, I always guess right. So this is our neighboring node. The new mask is something, the older mask, one left shifted new node or times. So this is a new mask. So if I have visited that new node with the new mask already, if I have not visited it, I'll insert in my visited array. I create a tuple for that, and I push it in my queue. Simple as that. This question is not very difficult. The only thing that we have to handle is the mask and the node. Okay, done. Yes, let's do it. Let's do it together. So this question is really interesting, how we are handling the repetitive things, not to call the repetitive things again and again. So it's really interesting to see these questions. So if you want to try this question, I'll paste it in the chat. Try it. If you don't, if you feel like you're not able to, let me know. I'll explain this again. I'll try to code this out again, because I have already coded this recently, so I'm not coding it out. I was just going through the logic, so it's fine now. So this is what my multi-source BFS is. Now word ladder to next question. Let's go to the next question, which is nothing but word ladder. Word ladder is kind of a very simple question, I would say, but they added some lead code added some difficult constraint just in order to do some more calculation, pre-calculation, so that you can understand it better. But if you know this solution is uh, way enough to handle all the, more than enough to handle everything. I don't know how this got into here, but it's fine. So word ladder, let's go to word ladder. Word. So word ladder is pretty straightforward. The only thing that we need to handle here is something we should not erase from our queue. Let's go one by one, and we'll be looking at those things. So the question is very simple. Let me remove this. We have a begin word, hit. We have a end word, cog. So I need to go from hit to cog, but the condition is, at once I can only change one letter to any other letter, and if we find it present in our word list, I can go to that. I cannot directly jump from hit to cog. I can change one letter at a time, and then we from there we can do it. So we have a word list, hot dog, dog, lot, log, cog. So from hit, uh, I can go to hot. From hit, I can go to hot. From hit, can I go to something else? No. So from hit, I can go to hot. After that, I can remove this hit. From hot, I can go to dog. From hot, I can go even to dot. D-O. No, I cannot go to dog, right? Sorry. I can go to dot. From hot, I can go to dot. There is a one letter change. And from hot, I can even go to lot. After pushing everything, I'll pop this out. Now from dot and lot, until and unless we keep complete our iteration, we won't be erasing it from. So from hot I can go to lot, I can even go to dot. So until and unless we complete our iteration, we won't be erasing our hot. So we erased our hot, we went to dot, and from dot I can go to dog. So we erased that. From lot I can go to log. We erased this. From dog I can go to cog. Remove from log. From log also I can go to cog. So this is kind of a simple. I just have to follow kind of simulation. I would say word ladder 2. Whatever it's saying, I need to simulate it exactly. And after simulating, we'll be able to solve this question. Okay. So this question is not that difficult. I would say I need to keep a vector of string, add a begin word, a current list. I'll get a current list. Original string is the last one that we took. If original string is end of the word and result dot size is 0 0, this is first time that we are pushing. Else if current list dot size is equals to result of 0 dot size, then only we'll push. Now we iterate over the original string. I took the current string from A to Z. So current string of J changed to this character. If it is present, count word map dot count. It is present in my word map. Then I'll push it in my current string, push it in my queue, and pop it back. After doing all the iterations of original string, then only we'll be erasing from our word map. That is my unordered map. So it will not get accepted because obviously it will give me TLE, but on other platforms this one will be accepted. So I'm mostly done with our BFS part. We can directly go to our DFS part. Okay. So let's start with journey to the moon. Can we change the ordering? No. So we have a journey to the moon question. Let me see what this journey to the moon is. So 1 is connected with 2, 2 is connected with 3, but 0 is connected with none. So it's a DFS how many nodes are connected together. The number of nodes that are connected, I'll add it with my previous count multiplied with the current count that we are getting from this DFS, and after that we'll add it in my total sum, and my new previous count will be updated. So it's simple. A DFS we need to find the count. So in DFS what we are doing, we are adding if count is equals to 0, one plus 1 plus 1 plus, so total number of count. This DFS will do the total number of counts, finding of total number of counts. So it's not that difficult. It's I would say on the easier side. The only thing that we had to find is this part, and we are good to go after that. Right, this is something for odd and even couple holding hands. uh, Minimum swaps needed. Okay, so we have our map. We keep every value with its corresponding index. Now we check. We took the first value. Now its partner will be something that value, and if the first value is even, then we add 1 to find the odd, and if it is odd, then we subtract 1 to find the even. So this is my first and second partner, and if the next index is not equals to the second partner, we need a swap. So we need a swap will do what? The I plus 1, that position needs to be swapped with map of second value, and I'll send this row and map. So this is the swap where I'll swap in my map also, and as well as in my uh, array also. Excuse me. So this was a good question. Reconstruct itinerary. So I'll go to this reconstruct itinerary. after a short break. So this question is also very good question. This is kind of a multi-set question, which will be easier if we use multi-set. And I'll also tell you what multi-set is exactly, how it works, uh, and why should we use multi-set here. So it's really good to know why we are using multi-set here, and why it will work, and why if there are more than one edges to same graph we can use multi-set. One of the thing that might come to everyone mind is how to use means when to use this multi-set in a graph question related to this. So this is very good question for a multi-set. And then we can go with DFS with stopping condition. So this question is also not that difficult, but we'll try to solve it. Okay, so I'll be back in 10 minutes. Don't go anywhere. We'll be doing these two questions. These two questions are really amazing and great questions. So we'll do these two questions, and then we will be going to detect cycle, where we'll learn lots of things: bipartite, directed graph, smallest cycle, undirected graph, and this is something two-edge technique that I'll tell you how we are using this two-edge technique very efficiently to solve anything related to detecting cycle or finding smallest cycle. So we have already done graph representation, and then we can go for shortest path. We have this Dijkstra's algorithm, we have Bellman-Ford, we have Floyd-Warshall algorithm, and how they differ we'll also do that. And then we have a topological sort, which is simple Kahn's algorithm. So this is also very good question. So we have lots of things to cover, and I'm really excited to cover all these things. After that we can go to search algorithm, which is nothing but KMP algorithm. So stay here, back in 10 minutes, and then we'll do rest of the things. back. Sorry, little late. Not little late. Just a minute late. Also.
अभी ऐसे ऐसे ही वालों को कॉल आया क्रेडिट कार्ड
Back. I'm back. Back. So let's solve this. Reconstruct itinerary. So this question is not very difficult, but this will teach you how to use multiset. Multiset in the sense I I am. It might be possible that from ATL I went to SFO. From ATL I went to JFK, and from JFK I can again go to SFO. And from SFO I can again go to ATL, and JFK to ATL. So I can see there are multiple routes I can go to a single place. Now the single place means that single place in degree is 2, is 3, somewhat something like that. So the same node can be repeated again and again. Means if I'm starting from JFK, see how this I'll try to plot the adjacency list of this, and let's see how we are creating it. So the first thing that we can see is from JFK. From JFK I can go to ATL, correct? From JFK I can even go to SFO. Now JFK's part is done. From ATL, from ATL I can go to JFK. From ATL I can even go to SFO. ATL is also complete. From SFO I can go to ATL. and nowhere else. That means if somehow I went to SFOs from some other direction, I should not go again to SFO from other direction. Means from JFK I can go to ATL. Correct. From ATL I can again go back to JFK. Now from JFK I went to JFK again. So this doesn't mean that I should not go to JFK again because I've already visited JFK. No, it might be possible that the flight went from JFK to ATL, from ATL to JFK back again, and from JFK. What was the question? JFK LGB. So from JFK to ATL, ATL to JFK, and JFK to suppose SFO. So this is the itinerary. So this should be our response, that JFK to ATL, ATL to again JFK. So it's not that I visited JFK, I cannot visit JFK again. I can, but this is the thing which we need to remember. From JFK I visited ATL, from ATL back to JFK. I removed this from here. From JFK I visited to ATL. I went to ATL, I can again visit to JFK. So I removed this from here. From JFK I can visit to SFO. From SFO, so SFO is removed from here. From SFO I can go to again to ATL. ATL is removed from here. From ATL now I can go to SFO. So I can, because it's there. So from SFO I cannot go to anywhere. So the itinerary will something go like this. So I need to be it in order. So that's why I created a multi-set of string which will be in order. So from JFK, so multi-set comes in picture when we are going to the same node again, but with different uh, something different, but with something different kind of configuration. Something configuration is different. So JFK, from JFK I went to ATL. I removed this ATL. From ATL I went back to JFK. And from again JFK we went to SFO. From JFK to SFO I removed this SFO. From SFO I can go to ATL. Again ATL. I removed this. From ATL I can go to SFO. I can go to SFO. I removed this. From SFO I can go to anywhere. From anywhere I cannot go to anywhere now. So this is our output should be. Let's see if this is correct or not. So from JFK I went to ATL, ATL, ATL again back to JFK, correct. From JFK I went to SFO, JFK I went to SFO, SFO to ATL, SFO to ATL, and ATL back to SFO, ATL back to SFO. So this is how our itinerary will be looking. So it's kind of using a multi-set. So it's a normal DFS. We took the string, we checked in my map that it is there. Then we erase from our map of node and call that node. Simple as that. So this is what our reconstruct itinerary was. DFS with. Now we have. Let's go to the next question, which is maximum path quality of a graph. So this is also very much similar to the uh, question I covered was I think connected components. No, not connected components. As in BFS, multi-source BFS, right? So DFS with stopping condition is very much similar to multi-source BFS, where we will be revisiting the same node again and again. We created a graph and the maximum time that we can. So if the same node is revisited again, I will not be adding the value to it. Adjacent node travel cost. If visited of new node is 0, that means this is the first time I'm visiting that node. I'll add the travel cost. Else I'll not add the travel cost. I'll only add travel time. And if my time exceeds my maximum time, I'll return. So this is my stopping condition, where my time exceeds my maximum time. I'll return at that point. Okay. So I think we are good with BFS and DFS. Let's go to bipartite graph detecting cycle. Mm, Maybe in directed graph detecting cycle. So this is very simple. When we have a directed graph, we need not to worry in that case. I'll just mark if my node is already in visiting state. So if it is already in visiting state, I'll return false. If it has been visited, I'll return true. And I'll visit it neighbor, will check. So this is very simple directed graph. Maybe I'll go with the undirected graph. Undirected graph is also very simple. The only thing is I need to keep track of the parent. Whenever I'm going to its neighbor, I should not go to its parent. And rest of the things will be as it is. Okay. Let's go for bipartite graph. There's something that we need to look at. Here is a graph is bipartite when the cycle inside of it is even or there is no cycle. So if it is a bipartite, the cycle inside, if there is a cycle present inside that graph, then it should be the nodes covering that cycle is should be even or there should be no cycle. We can easily solve this by alternate coloring. If there is odd cycle, then it is not a bipartite. So we have two colors, we can fix two colors. If it is an odd cycle, it will always come the adjacent node will have the same colors. If it is not, that then the adjacent node will have different colors. So it's a simple BFS technique. Started with this num start node. Any node we can start with. So this is the current node that we have. We popped it. This is the current node color. This is the new color that we will be applying to the next node. So the next node new color means new node color is equals to this color. That means they are same. So here we'll return false. If not, then we'll check if it is already colored or not. If it is not colored, then we'll color it and we'll push it. So bipartite is also complete, simple, not so difficult. Directed done, undirected done, smallest cycle. Now there is something called 2-edge technique. Now I'll tell you how this works. So don't consider this main part. I'll start with solve and this BFS. What we are saying, we have a graph, right? We have been given a graph. Graph can be of anything. So there are two edges between a graph. Now suppose this is a cycle and there is something with no cycle, correct? What we will do is in 2-edge technique, we'll pick an edge, that is there is an edge between 1 and 2. So let's make it this as start, like this. Let this make as end. So what I'll do, I'll start my BFS from start node, and I'll go to all of its adjacent node. Okay, I'll not add any edge between them. I'll go one by one. If there is an edge, it will create a problem. So I'll not add any edge. I'll check whether start to end, are we able to reach or not. If we are able to reach, we know that there is an edge between 1 and 2. I'll tell you how we are working with this. Is we are selecting two edge, we are checking the cycle. If there is cycle, we'll find the width and then we'll add that. So suppose initially we have something in my edge like 1 to 2, 2 to 3, 3 to 4 and 4 to 1. So we'll start building our graph from initially. So initially my graph will contain, suppose there are 4 nodes, 0, 1, 2, 3, 4, none. Adjacency list will be empty. There is none present. So 1, 2, we pick 1, 2. Now we check with the adjacency list, can we reach from 1 to 2? Because we know there is an edge between 1 and 2 already present. Now we need to know, can we reach from 1 to 2? No, we cannot reach because there is no adjacency list. So we'll do what? We'll add 1 to 2 in my graph. Next 2 to 3. Can we reach from 2 to 3? So 2 has no edge. No, we cannot reach. So we'll add it in our graph. So from 3 to 4. Can we reach from 3 to 4? From 3 I check 4. No, we cannot go anywhere. So 3 or 4 to 4 cannot be considered. From 4 to 1. So from 4 to 1 or 1 to 4. We'll have to add both side edges because it's an undirected graph. I forgot. So 1 to 2, then 2 to 1 also will be there. 2 to 3, then 3 to 2 to 3, then 3 to 2 will also be there. 3 to 4, then 4 to 3 will also be there. Now 4 to 1. So from 4, can I reach to 1? So from 4 I can go to 3. From 3 I can go to 4, but I will not do because this is the repetitive call. So 3 I can go to 2. So 3 I can go to 2. From 2 I can go to 3, but this is repetitive. I will not go. 2 to 1 I can go. So this was my start. This was my end. So see, from start, from 4 I can reach to 1. That means there is a cycle. So in this case we'll find what was the shortest height. So this is what we are doing over here. We created a visited array and we did a BFS, and whatever it will return will give me. So this is my start, this is my end, this is my edges list, and this is visited. I created a BFS. If the current node is the end node, then we'll return the length. If not, it's the same procedure. Go to its adjacent, find its neighbor. If it is not visited, mark it as visit. it and push it in my queue with one extra line. So this is how we do the smallest cycle. Now 2 edge technique was something which I did with the smallest cycle. We have 2 edge technique, 2 edges, and the edges list will iterate to over those edges and find whether we are able to reach our end or node or not. So in the 2 edge technique we have detect cycle in the graph. We can detect a cycle in the graph, find the smallest cycle, find the largest cycle, redundant connection in a graph. If there are redundant connections in the graph, that also can be figured out with this. Redundant connection, what is this? He's saying redundant connection is something which somehow will make a cycle. I don't want to make a cycle, I want to make a tree. This is what it is saying. To resultant graph is a tree. A graph will only become a tree when there is no cycle in it. So that is what we are doing with our 2 edge technique. We are detecting cycle. If there is no cycle, then it's fine. And if there is a cycle, so this can be this can also be solved with union and find. Simple, if they have the same parent, I'll just stop there. Yeah. So we are done with BFS, DFS, detect cycle graph representation, shortest path. Let's go with the Dijkstra algorithm. So Dijkstra algorithm is very simple. It's very much similar to BFS technique. The only difference is we will be keeping two things in our queue. We'll be using a priority queue and we'll be using a cost. So minimum cost at the top, and simple as that. We'll do simple BFS technique. Just I will add the edge weight. So Dijkstra algorithm makes sure that from one source point we can find minimum cost of reaching all other nodes. So this will be done in O of V plus E time. So shortest path is also done. Let's go for topological sort. Kahn's algorithm. Khan, whatever you want to say. Kahn's algorithm is something which which has a slight different approach than normal BFS. Here we keep our in degree things over here. So we have our in degree how many in degrees are there in a graph. So suppose Kahn's algorithm will always work in directly acyclic graph. This can be only possible when it is directly directed acyclic graph. So if there is a edge from 1 to 3, 2 also 3, 4 also 3, 2 to 4, maybe 1 to 4. So we can see there's no edge, there's no in degree. That means there is no node coming to this location. From 1 we can go to 3, we can go to 4, but from any other node we cannot go to 1. So in degree for 1 is 0, in degree for 2 as well as 0, in degree for 3 is 3, because from 1 to 4 from all of them we can come. In degree of 4 is 2. So this is what we will create initially for Kahn's algorithm for finding the topological sort, and whatever whoever's in degree is 0 will push it in RQ. See, so whosoever in degrees, we created our in degree array, all will push everything whose in degree is 0 in my queue. And now while loop is very much similar to our BFS technique. Will take the front node, will pop, will add it in my result, will go to its adjacent node and will reduce its in degree, and if its in degree is 0 we'll push it in RQ again, because from 1 I can go to 3, I can go to 4. 3's in degree will reduce to 2, 4's in degree will reduce to 1, but still we are left with some. So from 2 I can go to 3, I can go to 4. So from 2 I can go to 3, in degree will remain 1. From to 4, in degree went to 0. So whenever the in degree goes to 0, we'll push it in RQ. And that's it. From 4 we can go to 3. 3's in degree will become 0. It's 0, we'll push it to Q. So this is what topological sort can be formed in a directed acyclic graph. So if you don't know what topological sort is exactly, I would recommend you to try and visit some of the videos over internet. You'll get to know what topological sort is, and the algorithm is very simple. Now let's go for search algorithm, that is KMP algorithm, and then we'll try our dynamic programming, cherry pickup and cherry pickup 2. These two questions are really nice, so we'll try to revise it, and then we'll go to Google Sheet and we'll revise all the Google Sheet questions from start to end. So KMP algorithm is something of creating the algorithm is very much simple. We are given a string and we need to find a substring, whether needle is present in our haystack or not. We need to something find like this. So this there is one algorithm that uses O of n square, but here we can use O of n time algorithm, which is KMP algorithm for solving this needle and haystack part. So we have a string as haystack. Suppose AB, 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 CD, AB, CD, E. And we have a needle as maybe BCD. No, ABCD. So we see A matched, B matched, A and C they do not match. So what I will do, I'll go back here because A, it's BA. No, it's not. So I think we'll go. If suppose this is A matched, B matched, A matched, C did not match. So we'll go back here. I'll start matching from here because A is already matched, and AB. So sorry, we'll go back here. AB is already there. AB is already there. So we need not to go again to the same position. Next, A matched, B C did not match. We'll go back again to this position. AB matched. C now if I remove this, C matched, D matched. So ABCD is written. It's kind of creating some prefixes. I'm not able to create a perfect example for this, but it's kind of creating prefix for needle. So if we have A B C D A B something, this is my needle. What I'll do, I'll create some prefix. So for initially it will be 0. B if matches with previous, no. So 0. C matches with previous, no. 0. D matches with this is my previous PREV, no. A matches with previous, yes, correct. So we can say 1, and my previous will jump to B. Now B matches with previous, yes. So whatever index is there, I'll place it one more to it. So this will say that AB is already matched. Go back to this B and search it again. Need not to go back to start again to do everything. Now if we have AB more, my previous will go there, we will match it, no, it will directly go to 0. They match, yes. So 1 again, 2 again. So this is how we will create our needle, and our haystack will work very much similar to the needle part. So if haystack pointer and needle pointer matches, haystack and needle is nothing but this string and n, needle and this haystack. From this string I need to find this substring. So if I'm starting from haystack pointer and needle pointer, if they both match, they both will initially start with 0 0. So I'll move both the pointers. If they do not match, I'll check if needle pointer is at 0, I'll simply move my haystack pointer. Else if it is not, then my needle pointer will be something called prefix of needle pointer -1. It will move back and it will compare again from there. and if wherever my needle pointer reaches to m, that is total size of the needle, will return hashtag pointer minus m. That was the position where it all started. So this is kind of rigorous for me because I've already solved it again. So doing things, so we have longest happy prefix. So it's saying there should be some prefix which should match with the last one. It's simply what we created, needle. The prefix that we created for needle, we want same thing to be created over here. A, B, C, D, and A, B. So I need I just want to return matches with A, B. Last, how many longest prefix that we can have, which matches. So if we have C, then we have ABC matching with ABC. So we'll just create that needle part, and it's very simple then. This is just the needle part that we saw in KMP algorithm, and return at the last whatever the last will contain. I need to create a substring from that. So now the shortest palindrome. So this is also very much similar to uh, applying the KMP algorithm on the needle part. It's just we have been given only one string. We need a shortest string. So what I will do, we have our string str. We'll reverse the original string, and this new string is the original string, and I'll add this reverse string with a hash symbol to the original string. This will tell me that I've attached a reverse string to the original string. It's simple. Now what I'll do, I'll create a KMP, same as needle array, prefix array. I'll do the same thing here again. It's the same thing that we did in longest happy prefix. The way of representation is a little different, but it's the same thing. And at last, whatever the value it contains will be added. From 0 to s dot size, this is reversed s dot substring. Now KMP, last value of KMP will tell me what is the substring that we need to pick, and I'll add my original string with that. So that is the reversed plus original string will make the whole substring as shortest palindrome. So it's quite intuitive if you know how to solve this. So try this if you want once. If you didn't get it, let me know. I'll explain it again because I have already solved it. I know how it is working, the background. So try and solve this question, shortest palindrome. It's very good question. This longest happy prefix. These are really good questions. So try these questions by yourself. If you are able to solve it, even you can watch videos or anything. And if you don't know, if you are not able to, let me know. I'll explain it again very perfectly, very clearly. Okay, so now we can go with cherry pickup and cherry pickup 2, which is our dynamic programming. Okay, so the question is very much same. It has some tricks which I'll explain you. The trick is because the question can be solved even if you. So let me draw. So this is a 2D matrix. Cherry pickup is something we have three values. In we will have three values in this grid. First value is 0. That block is empty. If the value is 1, then there is a cherry, and if the value is 2, sorry, not 2, -1, then it's a thorn, I would say kanta. So 0, 1 and -1, these are the three values that this can attain. The question states that I have to start from 0, 0. I have to go to n minus 1 comma n minus 1, this last position, and from n minus 1 comma n minus 1 go back again to 0, 0. And in this way, from once we go from here to here and then from here to go back to here, in these two times you are traveling this grid, how many maximum cherries can you pick? The first condition is, if you are going from 0, 0 to n minus 1 comma n minus 1, you have only two moves, that is go right or go bottom, right or bottom, something like that. And if you are going from n minus 1 comma n minus 1 to 0 comma 0, you'll have two operations, that is go left or go up, right? Go left or go up. These are the conditions that we have. Now one thing I'm very much sure, that if we are moving from here to here and back to here, it'll take exploring all the path from here, and somehow we reach here, and then again exploring all the paths from here and reach here. So this is something we don't want. We want is, we go from here, we come from here in an optimal way. So in that case, what we can do, instead of sending one person from here to here back here, I can do what? I can send two people from here to reach here. Isn't it? Because in that case, I'll only have to explore this as once. From here to here, two people are moving from here, same place, and going from here to here, and then from here to here. Correct. So we need something like that. We need to approach something like that. So if you want, you can think over it for 10 minutes. I'll be back in 10 minutes after a short break, and then we'll solve this question. I have also the solution kept over here. uh, you want, you can have a look at it, but it will be much more better. It will be better for you if you want to try by your own. So try by your own. Let me know if you are able to solve it or not, and then we'll be solving it together. Okay, so we'll be back. I'll be back in 10 minutes. Okay, see ya. I am back. Okay. So yeah. So we were working on cherry pickup. So just a second. Just a second. Okay. So this cherry pickup question is very interesting. Let's see. What we did is we started two two person from same position from 0 0. So we started R1 C1 and R2 C2. This is coordinate for the first person and this coordinate is for the second person. We started both the person from the same position. Now what we are doing is we'll pick R1 C1 R2 C2. These are the base conditions that we will be having. Okay, just a second. Let me erase this. Is the shortcut key for this timer? I don't know. Okay. So we can see here, if R1 goes out of bound, if C1 goes out of bound, R2 C2, or if R1 C1 is -1 or R2 C2 is -1, that means it is a thorn. So we won't be going at those positions. So we'll return integer minimum, the minimum value that we can have, because we need to maximize the cherry. So we need to send some value which is very, very low. So I returned integer minimum over here. Now, if person 1 reaches to the end, we'll do what? We'll return from here that value where person 1 reached. If person 2 reaches to the last position, we'll return whatever value is there. Okay. If any one of them reaches the last position, we'll return. Now this memo, let's not look at this memo for first. Now suppose person 1 is here and person 2 is here. These are the two positions. Now we pick cherry. What we do from here and here, we'll call two methods for right and below. So if R1 plus 1, R2 will also go with together, R1 and C1. So there will be two values. If at this position there is a person, so if he goes here, then we have two values for these two. If this goes here, then we have two values for these two. So if person 1 goes one step, person 2 can go two steps, two different side direction. And if person 2 goes the second step, if person 1 goes the second step either side, the person 2 can go two directions. So these are the four directions that person can go, and whichever will give me the maximum, I'll store it in my cherries. Now we haven't calculated the cherries at that current position. These are the two positions. Suppose they have cherries, so then what we'll do, will pick those cherries and will return back. So what I will do is, now is suppose both the person are at the same position, both person are here only, person 1 and person 2. So this cherry should be picked up only once. Here whatever cherry is there, it will be picked up only once. So if person 1 and person 2 are at the same position, then we'll add only once the cherry at that, from that position. If they are at different position, we'll add both person 1, whatever value it will have and whatever value they both will have, will be added to the cherries, and I'll return that cherries. Correct. So this is how we are solving this question. The only thing that we needed to understand is, instead of exploring path from here to here and then back to here, we can directly call two people which will explore together all the paths, and we'll have a memoization obviously, for because there are four variables. So r1 c1 r2 c2 will be having four variables. So for four variables we'll be storing it somewhere. The constraints were low, so 51 51 51 51 can be adjusted. So at last will be returned, if we found anything, any value which is not -1, we'll return that value, and at last we'll store whatever value we have in cherries, we'll store it in our memo and return back. So this is how we approach to this question. Right. Now cherry pickup 2 is exactly the same variant, a little bit of twist, and totally fine. So in cherry pickup 2, I'll try to what should I say? Not try. You try it by yourself if you are able to solve this cherry pickup 2, because it's very similar to cherry pickup 1. What we do, we can go in three directions. The directions are this, this, and this. These are the three directions that I can go to. So here the two robots are, first robot is at here, second robot is here. These are the two positions robot can have. From here we have to start the three positions. It can go in three positions. So for suppose the two robots are here and here, what will happen? If it will go this direction, it can go this direction, this direction, this direction. If this goes this direction, again he can go in these three directions. If he goes in this direction, again he can go this three direction. So for one direction, the second robot can go in three directions, right? And what we are in every if I'm here, in every direction we are going, there is one symmetry that we are going to next row. We are 100% sure that we are going to next row. From here also, from here also, from here also, we are going to the next row. So for that we are keeping I same for both of the person. Even robot 1 is going here, we can go in three directions, but I will be same, it will be same too. So I can be common for both of them. J1 and J2 can differ. Right. So memo of I, J1, J2. is not equals to -1 will return memo of I J1 J2. This is just the memoization part. It's it's very very much same as the previous part. It's only for one direction we can go other three direction. I stored it in a map to know all the rest of the direction. So for one direction of one, I can go three direction for other. So this is what the two for loops is. And the same thing, if both the robot are at the same position, we'll add it only once. If both robots are at different position, I'll add at the different values, and will return those many cherries from here. So this will make sure that we are handling this, and we need to reach the end. So I will always move forward, right? So there will be a position where I will reach anywhere here in the last row. So whenever we reach at the last row, we will return whatever value it contains. So whenever we reach at the last row, if they are matching, if they are same, then we'll return only once. If they are not same, we'll return the both robots values. If the robot somehow from here reaches, this robot also reaches here, this robot also reaches here. So this is the common position that where both the robot will reach. So we'll return this only once, because obviously only one robot can take it. But if robot 1 reaches here, and if robot 2 reaches here to these positions, we can return the sum of these two, because they are at different positions. So this is what this is saying. So this is how cherry pickup 1 and cherry pickup 2 solves. If you'll have any doubt, let me know. I'll try to solve it again and explain you in a better way, and I'll try to explain you in a better way. Okay, so I think we did revise all the things. We revised the graph, we revised the searching algorithm, we revised the dynamic programming. We'll try to keep these things in our mind. We'll not forget it, right? Now what? Let's go to practicing questions. Now, as I've solved many of them, but I think most of the questions I had solved in 2021, 2022. So most of the questions I forgot how they are being solved. But I'll try to recover all those things by solving those questions again. And also I was thinking of something. I had some few videos, few interview experiences on YouTube for interviewing.io. I saw this yesterday. So they do what? They replicate the same thing again. So what they do is Is there replicate the exact interview experience with you? So uh, how we solve the question, how to approach to a question, what to ask, how to discuss, everything, how to explain the approach. Everything is very good here. So this is for other top companies. This is for Microsoft, Google, Facebook, uh, Amazon. Interviewed by a Snapchat engineer. So there are lots. So if even if I look at one of the playlist of them, there are lots of question. There's one alien dictionary. So these are sorted in maybe is there any kind of no sorting, no. So these are 3 years old. The most recent is this one, which is I think 4 months old. Rate limiter. So these are the questions we can try solving these questions. So it's a technical interview with a Google engineer. Core wars in red code. I don't know. Java interview with a Google engineer. Maxip system design. C++ interview with a Google engineer. So this is actually a good. So if you want, you can uh, go to this playlist. Or maybe I'll also try to share the link over here. You can try this if you want. They provide really good content, I would say. Okay, so let's get back. I was thinking of picking a question which is not solved. So we can start from back last. So the question is find the safest path in a grid. Okay, let's try. Let's understand this question. So we are given a zero indexed 2D matrix grid of size n cross n, where RC represents a cell containing a thief if grid is 1. Okay, if the grid is 1, that means it's a thief. An empty cell uh, empty cell if it is a 0. So you are initially positioned at 0 0. In one move you can move to any adjacent cell in the grid, including cell containing thieves. Okay, including cell containing thieves. So I can even move to the cell which contains a thief. So it says the safeness factor of a path on the grid is defined as minimum Manhattan distance from any cell in the path to any thief in the grid. Return I need to return the maximum safeness factor of all path leading to cell n minus 1 comma n minus 1. So I'm at this position. I need to find a safest path. And what is the Manhattan distance, minimum Manhattan distance? So I need to find the maximize the minimum. The question is something like to maximize the minimum. Means maximize the minimum. So whenever I get these kind of things in my mind, there's two way which strikes in my mind. The first way is the binary search to maximize the minimum, and the second approach is dynamic programming. How can we maximize the minimum? the the question is something like this. So first thing that comes to my mind is find all the distance, Manhattan distance, from thieves to every other node wherever it is 0. Find the minimum closest thief possible. So this kind of this can be done using a BFS approach, where multi-source BFS, where we have all the thieves placed inside a queue at once, and then we'll explore all the paths from there, and we'll check whether it is minimum or not. If it is minimum, we'll store it, else we'll not store it, and we'll move forward. Right. So maybe we can make thieves as -1. The distance is from here to here is Manhattan distance 1 1. This is 2 2 2. This is 3 1 2 3 3 3 3. Again 2 2 2, because this is closer, not this. 1 1. So this is the Manhattan distance. Now we found the Manhattan distance uh, from inside all the grid. Now we need to know, starting from here, we need to reach here. We can apply a DFS approach for this. From here, if I reach here, what value it contains will be directly returned. So minimum of all the recursions, and then whatever value is, we'll try to maximize it. So this will contain what currently we have 3 in my answer. I can explore all the 4 paths from here, and whatever paths will give me the minimum will be stored over here. 1. So out of 3 and 1, which is maximum? Which uh, so initially it will be 0, right? So I need to maximize somehow the minimum one. So I found the values everywhere. I'm starting from here. So the closest thief is at a distance of 3. If I go to here, the closest thief is at a distance of 2. Right. If I go here, the closest thief is at a distance of 1. The 2 2 2 2 2. So you'll again get 3 from here. Hmm. Now I need. Uh, Now I need to know how the DFS will work. I need to reach from here to here, keeping the maximum distance from the thieves. So we can take the maximum out of them and then find the minimum. Right, it's just the opposite. Minimize the maximum. Can we think like this? So let's suppose we are at this position. So from here I can call 4 values from here, this and this. These two are the values that I have already visited. So they will return int min. Suppose they returned int min, and I am uh, maximizing the values. So we'll get 2 and whatever value it contains will be updated with 2. From here I can go here, I can go here, I can go here, I can go here. So I've already visited this int main 113. So maximum is 3, 3 and 2. It's 2 again. So suppose we reached here, we return this value to here. Int mean maximum of them is 3 and the value at that position 2 will be returned. So it's something, whatever we are getting from surrounding, will take the maximum of it and compare it with the current value and return. This will do the job. Can we do it in one go. From here we search the maximum value. We go to the maximum value. From here we search the maximum value. We go to the maximum value. Search the maximum value. We go to the maximum value, and from all those maximum value, we got whatever the minimum value was there. We'll keep it. We'll tell that okay, this is the maximum distance. Yeah, correct. Don't do that DFS and all those things, right? We could have reduced. We can reduce the complications. So now what we need to do is we will be creating a BFS approach. Maximum safeness factor. Which will have two things: pair integer comma integer q alike trait over the grid, and if grid of I is equals to 1, that means it's a thief. We can take some space, extra space, or even we can do it there only. So we'll do what if the grid of I is 1, I'll make that grid of I j as 0. Okay, there's only one loop I added. So I'll make that 0, and also I'll push that I comma j inside the pair, and if it is not, then I'll make that grid of ij as -1. That means we haven't visited that yet. So now while now what if source contains a thief or the destination contains a thief? In that case, it will always be 0, right? The values will always be 0, even if the source contains a thief or the destination contains a thief. So I is nothing but q dot front first q dot pop, removed that value. Now I need to explore its neighbors, and I need to explore those neighbors which are -1, right? Because the values already. So for neighbors, I'll do what? Auto. It's the 4 direction. So we can make a direction vector. Direction will be 1, 0, -1, 0, 0, -1, 0, 1. So these are the 4 directions that we can go to. (1, 0, -1, 0, 0, -1, 0, 1). Correct. So these are the 4 directions that we can go to. We'll iterate over these direction. K is equals to 0. Now int new I. New I is k directions of I of 0. Int new j is directions of I of 1. Now these should not be out of boundaries. So new I is lesser than 0, or new j is lesser than 0, or new I is greater than or equals to grid dot size if it goes beyond, or new j is greater than equals to grid of 0 dot size. In these all case, I'll continue, and even grid of new I, new j is not equals to -1. If it is not -1, then also we'll continue, because we have already visited that position. So now what I will do is I know that that position is a -1. The current position value will be added +1 to it. So int new distance, maybe new distance is equals to grid of I of j +1. So q dot push new I, comma new j. I pushed it q. So grid of new I, new j will also be updated with new distance. Let's see. Okay, so this will do what? This will update my grid with the Manhattan distance. Now simply I have to start from 0 comma 0, and in all the 4 direction, whichever will be maximum, I'll go to that direction. So while queue is not empty, so after that queue will be empty, I can use the same queue. So what I will do, queue dot push 0 comma 0, and while not queue dot, so I need to explore all the 4 direction, and whichever is maximum, I'll go to that direction. Okay, so I'll take my ij and I'll pop it. hmm I need to find the maximum value from all the 4 directions. Max c is equals to 0. So this is new ij. If any of the new direction is -1, so new direction, the distance, so max is equals to maximum of maxi comma the new direction. So I got the new direction, but I need to travel. I need to push into my queue. That new. Hmm. I should be keeping the cost current till now. What is the minimum that we have? And I need to compare with that also. So I found the maximum that I can go. I'll take the maximum one from all the 4 direction. I took the maximum. So from here I can go to this direction, but the cost will be minimum of this and this. And I'll mark this as -1. Okay. Mm. I'll try to prefer to go to the maximum value, but whatever value we'll have, we'll compare it with the current value and return the minimum. Can I try the DFS? Let's try it. Int I, int j. The base cases will be very much same to this. So instead of new I, will be I, new j will be j, new I. I am maximizing. Val of current grid is I, j, and grid of I, j will be -1. Maxi is equals to maximum of I plus 1 maxi comma dfs of I plus 1 j and grid I plus 1 j, uh, I plus 1 j, I minus 1 j, I j plus 1, and I j minus 1. We we found the maximum of all of them. Now grid of I j will be placed with return value, return minimum of. Let me check. We did not even reach all the values. Why? So if ij is equals to 1, directions of k of 0 direction, new I, new j, new I. I did not understand why it stopped. What happened? It's the BFS that is stopping, right? We made them 0 and the rest of the values. So what I can do, I'll just print it over here to see if it is there. 0 and rest is -1. The thirst is also they are 0 and rest is -1. It's fine. This is fine. And also I pushed it in my queue. Whoever was thief. Mm. See out I. See out J. What mistake I am doing? This should not be any type of mistake. For one, it is 0 0 2 and 2 2. 0 1 1 0 and 0 1. But why? Oh my god. It's I plus. Shit, dude. So this is working fine now. My DFS is output is int min. Breakfast search plus binary search. Yes, this is fine. This is what I did in the first part. The maximum safeness factor for each path exists from source to cell. Oh my god. So I'm using a binary search here to fix a value that 3 value lesser than 3 is not acceptable. Greater than 3 is acceptable. Lesser than 3 is not acceptable. And I have to maximize. So I'm using the binary search. Is there any other approach to this? Plus greedy. We are doing this the same thing that I did here. It's fine. Priority queue with the highest priority. We are pushing in our priority queue. We're keeping cost. So we will push the minimum current of 0. Everything. Okay, oh my god. I don't know, this DFS would have worked, dude. I'll try it again, this DFS part maybe, and try it because the BFS is same as DFS. So I'll try it once more after a short break. After 10 minutes of break, I'll be back again, and then we'll be continuing this. I think it's working. I'm almost very close to the solution. So I'll try it once more. I'll be back in 10 minutes. Okay, I'm back. Okay, so I was very much close. I don't know. Uh, there's one thing that I know is if one base case is missing, I think if grid of I, no, not I. If I is equals to grid dot size minus one, 0 dot size minus one, then I'll return grid of I of j, whatever value it contains. This is the base case that I was missing now. Let's try and submit it. See if this works. Now we got a TLE. Why we got a TLE? Is it because of DFS? Because this is taking O of n, m cross n. This DFS will take lot more time. So instead of this DFS, I can use a priority queue. So maybe we'll give TLE because we are having 4 recursion calls every time. Vector, and what I need is I need the largest value at the top. So if I'll do greater, I'll get the smallest value at the top. I'll get the smallest value at the top if I do this. So now BFS is better than this. So what I can do is I'll apply the BFS approach here. Now PQ dot push with a cost of grid of 0 comma 0 comma 0 comma 0. Now while not PQ dot empty, so like, can we do memoization over here? We only have so 400 cross 400 memoization DP can also work. Let me try. Instead of directly jumping to BFS, let me try. What I'll do is I'll create a 401 of and right here Memo as negative 1 comma size of memo. Let me see, for the normal test cases this should be accepted, right? Okay, so if memo of ij is not equals to negative 1, the submission I got a daily. Let me try to use this test case. No, this time it's wrong answer. Expected is 7, my output is 6. Okay, so no memoization. Int cost is pq dot I and j. Now this is the priority queue. I need to find the minimum cost. Now if my I is equals to then I'll simply return the cost. If not, I'll iterate over the all the directions. Where is my directions? I'll iterate over all the directions. I'll get the new directions. I'll check the new directions. Uh, 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 uh. So I'll mark this current as -1, and this will be something as, if it is -1, that means we have already visited that. We are not visiting that one again. So now I need to push it in my queue. Now, so new I, new j. This is 3. I will keep in my queue. Q dot push. First is minimum of cost, comma grid of new I, new j, new I, comma new j. PQ, it's a priority queue. I'll have to keep it outside. There is some bracketing mistake. Yeah, again. Right, mark this as -1. If it is reached, pushed, else is valid sale, these conditions will be there. And so mark this new I and new j also. Because we are keeping a priority queue. Tutorial. Why it is n square log n? Okay, there is n cross n matrix. So this was a nice question and a different, little different. Memo I So maybe I'll keep this. Safest. What was the question name? Safest path in the grid. So the comment for this is do do a multi source BFS to find the Manhattan distance. Use binary use a binary search to find a value and using BFS or yes, use priority queue and keep maximum at top and find the minimum at the adjacent. Nice. So design a stack with increment operator. This is one of the very good question. So we have a stack with increment operation. Uh, we are given a custom stack. Int max size. Initialize the object with max size, which is the maximum number of element in the stack. Okay. So let's say let's say we have a stack function. What we do is we need to push, we need to pop, we need to increment the bottom k element of the stack by value. If there are less than k element in the stack, increment all the elements in the stack.
आवाज कम करूं?
नहीं आ रहा इधर.
Yeah.
Use NVIDIA RTX voice to reduce the background noise. It will reduce the background noise way better. By the way, I'm also live on YouTube. Oh, nice. Nice one, Preston. I will try to use NVIDIA. You can also paste your channel link if you want over here. NVIDIA RTX voice to reduce the background noise. It's really lot of background noise. Okay, I'll try to fix that. Okay, so where were we? We were implementing the stack question. So increment operation will do what? So we have a given array of size of some specific size max size. This is my stack, and I'll creep one more thing, which is the increment. So if we push one, I'll have a pointer which will say that where the what value is currently pushed. So it will be initially -1. I'll make it -1. A pointer pointing at -1 currently. So push will do what? Push will push 1 into array. Again push 2 into array. So my pointer will shift to here. Again it's an empty which is nothing but pop. So I'll pop this, I'll move here. Simply my pointer will move here. I don't have to pop any value. Then push 2, then again 2, then again 3, and then again push 4. So 4 will not be pushed because the maximum size is 3. Again increment last key values with 100. This is my, so last key value, my pointer is at here. If my pointer, if k is lesser than pointer, so threshold value which is this, whichever will be minimum, I'll pick that, and in that threshold value I'll add that value. So this 100 will be added over here, and then increment 2 with 100 again. Now pop 3, add it with 100, pop so it will be 303 will be returned. Sorry, 103. 103 will be returned, and this 100 will be added over here. So 200 will be added. Now again if we pop, 202 will be returned. (103) return, 202 return. Again if we pop, we again return. We again add 200 over here. 201 will be returned. So something like that. So we need to keep a max size, and we need to keep an increment operator which will do all the operations. So this is how we will do it. I'm not going to solve it because I know how I'm solving it. So current index, rank transform of an array. Do you have anything except sorting it, sorting an hash map. A map will do the job. Okay, if Lee has done an unlog, and then I'm pretty much sure there's no better approach to this. This is a good question. I'll try. I'll not solve this question, but I'll do it again. This is very good question and very intuitive question. If you want, you can try this. So what the question says, your I is lesser than j. Nums of I is also lesser than nums of j. The width of such ramp is j minus I. I need to return the maximum width of the ramp in nums of I. If there is no ramp in nums, return 0. So this question is very beautiful question. I need to find the maximum width of the ramp, where the condition is I should be lesser than j and nums of I also should be lesser than nums of j. Exactly, values should be lesser, not inside of that range. Values can be anything, like 5 and 0. See, 0 is lesser than 5, right? Inside of it doesn't matter. I'm not cared or concerned about that. I need to find the maximum width of something like that. So this question can be done using some operations, pre-calculation. Like, let's calculate the maximum from left and the minimum from right. Okay, so 5 is greater than 0. So until and unless 5 is greater than 0, I'll shift. Now 6 is greater. Now my this will shift until and unless I find a value which is greater than. So 5 and 0, this was the last position. This is the maximum width that we can have. Let's try the second example. Let's confirm this. 98101944041. 981000000 left max. From right, 144499999 and 9. The value can be equal also. So I pick this. Until and unless I see a value smaller than this, I'll go 0 0 smaller than 1, smaller than 1, smaller than 1, smaller than 1. This is even equals to 1, fine. This is greater than 1. So till here I can say. So from here till here I can have a width from 2, 3, 4, 5, 6, 7, 8, 9. So 9 minus 2 is nothing but 7. 7 is the maximum width. The moment I find a value which is greater than this, I'll move this pointer and I'll try to find a value which is greater than this. Now I'll move this pointer. So this is also one of the possible answer, 9 and 9. So this was really amazing question, I would say. A different logic. Overall was really nice. So I'm not going to solve this. I've already solved this question. So I'll create a left and right. From left I'll return the calculate the minimum. From right I'll calculate the maximum. And then my left and right pointer, 2 pointers will run. Something like this. Okay. Maximum area of island. Okay. You are given an M cross and binary grid. An island is a group of one connected 4 directionally. So there are only 3 islands, right? The, the area of the island is the number of cells. An island is a group of ones representing land. Connected 4 directionally, horizontal or vertical. You may assume all 4 edges of the grid are surrounded by water. So wherever I see land in the boundaries, I'll do a DFS and remove that. I'll make it water. Now the rest left is the land, and then I'll find the maximum area by simply iterating over it. Now we have one question was there, Pacific and Atlantic. CIS. Atlantic water flow. This question is very popular. I don't know why, but still, yes, it is. So what are we exactly doing is we are creating two. So for Pacific I have a, for Atlantic I have one. So I'm iterating over column, height of 0. That means this and this. No, sorry, this and this. Column from here I started. I'll iterate. I'll go till there where I am getting values greater than the current value. Heights its height, it's specific. Previous value is obviously int men, so I can reach here. I went here with taking previous value as current heights of ij1. If this value, if heights of ij is lesser than, so wherever till here I can go. So now I'll check where it is not -1. I'll push those coordinates. This and this and this and this. So from 6 I can go to 7. So if I'm going this 6, zero, 1, 2, 3. 3 0 is also there in our answer. So I want to know both direction. Okay, uh, let me see for the first what. Okay, so this was Pacific Atlantic Ocean is also good. Okay, see maximum swaps what which you can swap two digits at most once to get the maximum valued number. Return the maximum valued number that we can get. Uh, hey, hi Valentine. The question is, hello, I just joined. Nice. Can someone answer some specific question about mobile app development, or am I in wrong place? Most probably, yeah, you are in wrong place. I would say because I'm not very much into the mobile development right now. Uh, I'm more focused on data structures and algorithms. So I'm not sure that I'll be able to answer to your questions or not. So mm, sorry for that. But yeah, if you have any questions related to data structures and algorithms, you are most welcome. Uh, if it is kind of a generic question, maybe how to do mobile development or something like that, then it's fine. Or if it is something related to core of mobile development, then not sure that I'll be able to answer. Is there anyone in your current circle who may have this knowledge? Um, mm, mm, for the mobile development, yeah, I know a few people for mobile development. So, okay, so you're seeking something quite specific. Okay, then I think I won't be able to answer currently. So you can look something in Copilot or ChatGPT if you want something specific answer. I think they can answer more accurately for the development part. I was curious if they would be willing to discuss a mobile game app. Okay. So uh, I just want to ask you one question: that which type of language are you using? Is it React Native that you are working on for developing the mobile app, or something else you are working on? Because I okay, live feed. I'm not sure about live feed currently. I may ask the questions that you are asking in with my friends who know the mobile development, but these live streams, I'm not sure about it. I don't have any development skill. It's something that would be rather large project with potential to get millions of players. Hmm. Okay, for this, I think you need to connect to someone who is very good at it, because I know React uh, JS, a little bit of React Native. One of my friend knows React Native, but I'm not sure that he or she will be able to solve these large scale scalable thing. Okay, I have done years of market research on this specific plan, and across several mobile games, 100 by 100 players say they would play this today and ask for release date. Yeah, possible. They may have connection. Okay. mm, I'm not sure she'll, she or he will be available right now, but if somewhere we can connect, might be possible. Then if you have something we can connect to, might be I can give you some people who can, or who are willing to. Is there a way to get my contact info to you? I have Discord. Yes, I do have Discord. To let me check. I don't remember my Discord user ID. Just give me a second. I'll send my Discord ID to you. Okay. this is my Discord. If you want, you can connect me on this Discord. Then we can have some talk regarding that. Yeah, I got you. No problem. Let's have a talk related to this. Uh, Maybe after my stream ends, something like that. So okay. Uh, yeah. So okay, let's get back. Actually, I am. It's late here. So can I have a lunch break? Or 25 minutes is more than enough, I think. After this lunch break, I will start solving more questions because I want to complete all these questions today. Maybe the one which is a harder one or I haven't done yet. Maybe I'll skip. Oh, I think only it's one there. So I'll try to complete the rest of the questions and then I'll go back to this question and I'll try to complete this one too. So I'll be back in few minutes after having my hunger quenched something. So we'll be back in some time. Lunch break. Bye bye. See ya. Hello, I am back. Okay, so where was I? So we were starting from last, and so the question was maximum swaps. So at least I can swap two digit, at most once to get the maximum valued number. So I need to swap it. Right. So for this, one way to approach is from left hand side. I know if I see a number from left hand side, if I look at it, I'll get to know the number which is greater than the previous number. If we swap the number with that, I'm sure that I'll get the number which is maximum after for only one swap. So this can be done using uh, array. I'll store everything inside a array, all the digits, and do the comparison and swap it. And one thing that I need to make sure that if it goes beyond. So is there anything more specific? Greedy to pass. I'll have to have a array suboptimal greedy. What is the space complexity of n, time complexity of n? Obviously, this is the approach that I was. This is I think way more simpler than I was thinking of. What code did I wrote? So I converted into string. I checked the position. If str of I of j is greater than str of I, so I will start from 0, j is starting from last. Okay, so which value to swap? It might be possible that this one is 8, so I'll swap 8. From last I'll start comparing. If strs of j and strs of I, if index is equals to -1, index is equals to j. What's this index? So I'm finding the maximum value from last. The maximum who is greater than this. Simple. The max digit which is greater than this, swap with that. Correct. So I'll skip this forward now. All O1 data structure. So this is not that difficult. So the question is, we need to design a data structure to store the strings with the ability to return the strings with minimum and maximum counts. Implement the all one class. Just a second. This question, is it moving I? We are, for every position we are checking from last. Correct. If we get any. So this increment string will do what? Increment the count of the string key by 1. If key does not exist, the data structure will insert it with count of 1. Decrement decrements the count of the string key by 1. The count of the key is 0 after decrement. Remove it from the data structure. It is guaranteed that key exists in the data structure before the decrement. Get max key. Returns one of the keys with the maximal count. If no element exists, return an empty string. Returns one of the key with the minimum count. If no element exists, return an empty string. Note, each function must return in over 1 average time complexity. So we get increment hello. Key and its count, count and its key. So I have this hello as a key, and corresponding to that I added a count, and based on count we added a key, added the key. So this is obviously a map, so it will be sorted. So max key will be from end. If it is begin, then else max count return. If it becomes end, fine. Else this. And increment is something. So it's fine. I think it's not very much difficult. I just need to make sure that we are incrementing and decrementing correctly. So all O data structure done. Remove it. Longest repeating character replacement. Let's see. So you are given a string s and an integer k. You can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operation. Replace the two A's with two B's and vice versa. If I replace this A, so it feels like a sliding window approach. So if there are two k is 2, so two different characters we can take. Now if k becomes 3, if the characters count becomes 3, unique character count becomes more than 3. Okay. One thing that I need to make sure is k can replace only 2 characters, right? So if any character's frequency increases from 2, we won't be able to uh, see, uh, no, not any character. Something my map will contain only two unique characters. My map can only contain two unique characters. Correct. And if there is any extra character that is being inserted in the map, and if map grows to 3, uh, no, no. Need to understand this. I'm saying that B, A. A. So what I'm saying, my K is 2. K can replace any character. Mm. If K is 2, you can choose any character of the string and change it to uppercase. So any character can be changed. So at max 2 characters here can be changed if I'm taking this. So this, so A B C A. There can be if we have 3 characters. I need to know which one is the dominating one. In this substring A is the dominating one. I need to know rest of the characters frequency. If it is crossing more than 2, we'll have to do something. So the brute force approach for this will be something just taking the substrings and replacing the characters. So suppose A's frequency is 2 and I can replace at most 2 characters, right? Now B comes, there are 2 characters in my map. K can even exceed to my S dot length. B has 1 character. Now again A came. A has 3 character. B now became 2. uh, it might be possible that there would have been C. So B with 1 and C with 1. This can also be accepted because K is 2. So I can replace these two characters with A, which will give me total cost of 5, total length of 5. Now how can I handle this part? And A, B, A, B. These are the two strings, two ways to handle. So if I will be able to handle these, a substring can contain any characters, but the character which is character frequency which is dominant. So this map will go max of 26 size, and suppose every time if I am iterating this 26, which goes 10 to the power 5 into 26 of size, which is acceptable. So what I'm thinking to approach is, I will try to find the maximum in this. I'll try to find two things, right? Maximum frequency character and total frequency. So maximum frequency character, or maximum frequency, I would say maximum character frequency, C is 3 and total is 2, sorry 5. So 5 minus 3, which is 2, it can be adjusted, can be adjusted. And if it is not possible, then what I will do is I will reduce one character from last. Now what will happen is, even though it is a maximum character frequency, uh, 2 4 minus 2 will again be 2. So I'll shrink my uh, window and again check this same conditions. This needs to be a function which will check and send me true or false. Is it possible or not? Is it possible or is it not possible? So something like that. So what I will do is I'll have a sliding window start, left as 0, right as okay, right as 0, I'll be having an ordered map. I don't need to have a map of character corresponding integer map, or I'll say frequency map. Now while my r is lesser than s dot size, so what I will do is I'll add it s of r in my frequency map, and every time my r will increase. Okay, so we have this frequency map added. Now condition check. There will be something while my longest repeating character, while valid frequency map or is valid frequency map is false, while not is valid frequency map, I'll be doing what? From frequency map s of l will be reduced. Now if frequency map of s of l is equals to 0, frequency map dot erase s of l, and left will be plus plus. Now while left is lesser than or equals to r, and after this I'll have a answer variable, or longest string is equals to maximum of longest string, or r minus l plus 1. Longest string as 0. Now I need to check this is valid frequency map, so this will contain my frequency map as well as my k. So based on k it will return a boolean value of is valid frequency map. It will take a map as well as integer k. Now if what we'll do is we'll have max character frequency and total frequency. Auto it is equals to frequency map dot begin, while it is not equals to frequency map dot end. So max char frequency will be nothing but maximum of max char frequency and it of second, as well as total frequency plus is equals to NIT will increase. Now condition is there if return the max carrier frequency minus uh, max total frequency total frequency minus max carrier frequency. If this is lesser than or equals to k, will return true. Else it will return false. And at last, longest string. So let's add few test cases. AA, BA, AA, BAC, K is to BA, B. Okay, so let's card accepted. Nice. So I did solve it in 2022. How I solved it. Sliding window plus binary search. The window size was minus the max frequency character. Hey, so why I need this? Can't I reduce it? So the max frequency character, total frequency is the something the length of the window, and max character frequency we can keep tracking it always. So instead of doing this again and again, we can keep track of this. So is valid frequency map. Instead of this, we can keep two things. This max. Sorry, what happened? Max character frequency. No, max character frequency we need to find. We'll have to find because it will change. Total frequency may not change, but still even we are iterating over the character. The maximum frequency we have seen in any window yet. Why in any window? This is O of n approach. Okay. What is he doing? Now this time max frequency is still 3. But in this window, the maximum frequency that we can see. Okay, that will be once. Max character frequency can be same every time. So it will be max character frequency, comma and total frequency is R minus L plus 1. So max character frequency minus total frequency is greater than K. End minus start plus 1. Sorry, I did it opposite. It should be I don't even need this then. Correct. Nice. Okay, so this is O of n time complexity. Earlier I was using is 26 times O of n time complexity, which was also accepted. But this is better. So it's very simple and trivial. It's just a simple stack question. I don't know. Was I able to solve this using string? No, 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 no. I was trying, but it's a stack character. Stack of characters. Meeting rooms 2. I solved it recently. It's 16 October. It's on my birthday. So it's not that difficult using the priority queue. So meeting room 2 is also fine. Best time to buy and sell stock. You're given an array prices, prices size. This is fine. I need similar question. Best time to buy and sell stock 2 and 3. Let's try this. Two, three, and maximum profit from trading stocks. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell the stock. So sorry, you're given an integer array prices. One day you may decide to buy and or sell the stock. You can only hold at most one share of the stock at any time. However, you can buy it, then immediately sell it on the same day. That's the benefit of buying and immediately selling it. Uh, Find and return the maximum profit you can achieve. So if we have an buy indicator, so we what will happen is buy sell. This much price will be reduced from whatever we will get profit from this. I'll reduce this much price from that. And uh, if I'm buying, if I'm not buying, it's simply calling the next index. So if I buy, next time I'll sell. So if I'm selling, sell will also have two options: either I'm selling or I'm not selling. Is it even running? That's what I thought, dude. I am take and sell, not take. And now I'll be needing buy and sell for this and indices. For indices, we need memoization. So memoization, I need to have memoization over here. So so I can declare a memo and it will be accepted. What from what I know. See, 1, 2. So if memo of idx comma indicator, it should be indicator, is not equals to -1. So instead of that, this I knew that it will be accepted, but it will take stack space, that's for sure. Fine. Okay. Okay, not an issue. We'll try to solve more questions. After a short 10-minute break, I'll be back and I'll try to pick this question: maximum profit from trading stocks. Let's see what this holds. So after that, where we were, Longest spiral matrix, group anagram, lot more to go. Okay, fine. Back in 10 minutes and then we'll continue again. See ya. Hello guys, I am back. Okay. So the question is maximum profit from trading stocks. Let's see. Let's see what this question holds. So we are given a zero indexed integer arrays of the same length present and future. You are given a zero indexed integer array of the same length present and future. Okay, their lengths are same. Present is the current price of the ith stock and future is the price of the ith stock a year in the future. Okay, you may buy each stock at most once. You're also given an integer budget representing the amount of money you can m- amount of money you currently have. Okay, maximum amount of profit you can make. Okay, so let's see. One possible way to maximize your profit is to buy on the 0th day, first, second, third day, and fourth. So 5, 10. So this is maximum 10. Next year, sell all three stocks for a total of 8, 3, and 5. uh, 16. So the total profit that I'll be making is 6. So if I am buying, uh, I will be selling the same stock again in the future. So it says 5. So I'll sell 8. 2, I'll sell it at 3. And 3, I'll sell it at 5. So I need to maximize the profit, correct? So this can be done by recursion. I have the budget. Budget will reduce. Budget, what's the length of budget? It's 10 to the power 3 and it's 10 to the power 3. So 10 to the power 3, 10 to the power 3. We can create a 2D array of, I suppose that of, it should be fine. Right, it's fine. So what I can do is I can keep the profit maximized. Okay, so let's make profit my index and my budget. These are the two things that I'll be having. So idx will start from 0, present will go as it is, future will go as it is, and my budget will go as it is. So what I will do, I'll be returning this is my index and and the rest of the thing is this. Right, now if my idx goes greater than maybe n equals to present dot size, in that case I'll return 0. It's going beyond what we expect. Now what we have is we need to make profit. So profit is equals to, there will be two things, either buy that stock, so if I'm buying that stock, and either sell that stock. So if I buy that stock, or if I sell that stock, so if I'm buying that stock, what is the profit that I'll make? So it will be something max profit that I'm making here. Max profit will be nothing but maximum of max profit, because I have to maximize the max profit, and present, so future future of idx minus the present idx plus whatever we'll get from max profit recursion. I would call it REC. If I'm buying it, present future. Okay, budget is something I did not handle. If I'm buying, so I need to make sure if my budget allows me to buy the present stock. So if budget, if budget minus present idx is greater than 0 or even equals to 0, that's fine. So present budget minus present idx will be left for the future part. Now I do not buy stock. Do not buy stock. I'm not selling it. Right here, I'm not buying the stock. So it'll be same. Something same recursion calls will be made, but instead of adding this, I'll simply call for future, and I'll return max profit. So for the smaller test case, I think it should work. Yes, for the bigger test case, I need to memorize it. So mem set memo comma -1. I'm not passing memo. Memo of id x comma budget. And yeah, so this was not that difficult, I would say. Okay, we even solved this. There is one iterative approach to that, I think. Yes, there is. So wherever we are getting a profit, will be selling it. Buy it here, sell it here. Buy it here, sell it here. 4. Buy it, sell it here. 1. Buy it here, sell it here. Buy it here, sell it here. Okay, so now we are with largest rectangle in histogram. Let's dry run it once, because I know this question, I have solved this question. I just want to dry run this left fill max and right fill max. What it exactly does is this might help me in any other question. Alarm. Left max. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. This is left max. This is right max. Now what I will do is I'll check initially this boundary left for left max. So I'm checking if a value is 0. I'll put index. So one, if there is a value which is greater than that, I would happily remove it. If there's nothing, I'll set the boundary to be 0 and push 1 index 2. Now 5, if there was a value behind it greater than this, then it's fine. But if there is a smaller value, just a smaller value, so we'll do whatever value it contains. I'll add +1 to it and store it here, and I'll push 5 index 2 also. So 6 has a just smaller value, so index 3 to this and index 3 pushed. 2 2's boundary is 6. 6 can be removed, 2 can be removed, but 1 we cannot remove. So 1 plus 1, that is 2. 2's boundary is this, and 4 will be inserted. For 3, the boundary is 2. So sorry, 4. So 5 will be inserted. Same thing I'll do from right hand side. I'll insert the last index, that is 0, 1, 2, 3, 4, 5. 5 here, 5 here. The value is greater, I'll pop it. For 2 it's 5 again. I'll insert 4 here. For this just value is smaller, so 4 minus 1, that is 3, and 3 will be pushed. For this this 3 will be popped. 2 is the boundary, so 2 minus 1, that is 3, and 2 will be inserted. For 1, this will be popped, this will be popped, everything will be popped. So 5 is the boundary. For 1 will be inserted. For 2, 1 is the boundary, so 1 minus 1, that is 0. So simple. Now I need the height. I need to look at this value, this value, plus 1 into 2, that is 2. For 1, 0 minus 5 plus 1, that is 6. So 1, 2, 3, 4, 5. So 6. For this 2 and 3. So 3 minus 2, that is 1, 1 plus 1, 2 into 5, 10. 6, 3 minus 3, that's 6. So this is 10. Here comes 10. 10 is the maximum. So this is our answer. I want to solve this. No problem. I just want to solve this question. I know it's not that difficult question to solve, but it takes a lot of time, a lot of effort to move those pointers here and there, and have those conditions. Right. So we have two pointers. We'll take left top, left top, left row, column. These two pointers, this and this. These are the 4 pointers that I want. Okay. Left, top, right, right and bottom. So left is 0, top is 0, right is matrix of 0 dot size -1, and bottom is now, while condition will be if my left and bottom goes beyond, if my left goes beyond bottom, means if left is lesser than equals to bottom, I'll move, and right is top, sorry, top is lesser than equals to right. If this is the case, I'll move. So I'll iterate from here. So I need an iterator which will start from top, so for int I excuse me, vector int result. So what I'll take is while it is lesser than or equals to right, it is lesser than or equals to right, result dot push back matrix of left it and it plus plus. After doing this whole iteration, my left will shift Now now we have right pointer to shift this side, right? So while this happened, now my IT will be pointing to right. It will go till here, so it will start from left. So already 1 2 3 is pushed, so we need to push 6 and 9, something like that, right? So while IT is lesser than or even equals to bottom, I'll move result dot pushback matrix of IT will move something like this. So IT should be equals to left, right, left. So matrix of IT IT is this, bottom is this. So bottom will tell me now this line is also completed. My right will shift a little. Now it's time for bottom to shift up. So IT will start from bottom, while IT uh, IT. So my left is this, my top. So it will go till top, right? So IT is lesser than equals to my top. Matrix of I'm iterating this way. So my first value will be the last value, which is bottom. Right has shifted from here. So IT will start from right and will go till top. So bottom and right. Now this is completed and my bottom will be reduced. Now I need to go up. My loop will start from bottom, it will go till equals to my left. So it is equals to start from bottom while it is lesser than equals to left, result dot matrix of this it and top, because top has not yet changed. Now top will also move forward. So 1 2 3, I got 6 9, something 8 4 5 4. Okay, there is first loop went correct, second also went correct. So my right shifted here. It will go till top is here. So while it is greater than equals to top, it will be minus minus, and here also it will be minus minus, not plus plus. This is something wrong. It starts from right. Bottom right. So now from here I have to go there. So this bottom is from here I have to go till left. So then equal to left. While IT is gain. Okay. So 1 2 3 4 7 11. Oh, okay. Instead of 8 and 12 it went to 7 11. So it added one more extra character. So I'll have to add a condition. Left, right. This is left, this is right. This is bottom. If bottom one extra character. Top, left, right, down. Down is bottom. For me it's bottom. left went greater than my bottom. Break. If right, if right becomes lesser than my top, if bottom becomes uh, lesser than my left, it took me 25 minutes to handle all the cases, edge cases. My god, this spiral matrix is really bad. Grouping anagram. Is there any follow up? We can sort. Based on sort, we can keep all the values, and after that we can directly push it in our. So it's not that difficult. Unordered map. We sort it. We push it, and we return. Follow up. Could you do this in one pass? I haven't practiced uh, linked list question lately, so I will have to practice these linked list questions. Okay. So we need to remove nth node from the end of the list. See, one of the way to do is using recursion. Better than recursion is always to use some kind of iterative approach. So iterative approach is we have the head, we know the n. Okay, we know the size. No, which one to remove from last. So for first once, I'll do 1 2 3 4 5 4 3 2. 3 left, not 2 left. Make this 4 3. This is the 2. from last I need to remove. uh, okay, one thing is I know the size of the node, and then we iterate over the that node, and we found that node. We will keep a previous pointer and the next pointer with him with together, or the previous pointer and the current pointer, two pointers, and that will remove this node and join it. Now I need to do it in one pass. Doing it in one pass, we don't know the size of the list. How will I be able to remove from last if we don't know the size of the list? And this is what the follow up is. I need to do it in one pass. That means in one go I have to find the what should I say, the length of the linked list, and also at the same time I need to remove that node also. So what do you think, how is it possible for such kind of thing? How can we make it? Remove nth node from end. One pass. Recursion can help me. Calling from null. I'll call 0. This is 1, not matching. So I'll keep this pointer as my previous node. This is the node which I want to remove. So send this also. Or I'll send true to him. It'll do what? It's next to next value. It'll pick its next to next value and merge it, and I'll recurse back. Now these are the two way that I can see. One is recursion, that will take stack space, O of n stack space. And if we are not doing recursion, iterative will take 2 pass. It will take O of 1 time complexity, but O of 1 space complexity. It will take 2 pass. So let's see the editorial for this. It's a 2 pass algorithm. Advances by n plus 1 steps from beginning, while the second pointer starts. Okay. Right, correct. If n is 2, make a distance of 2. I just need to pinpoint that position, the previous position. When I'll reach this position, this node need to be removed, and this is null, so my right pointer will to null, and this will point to. So I'll have a distance of that much and move the two pointers. Oh my god, this was nice. For one pass, iterative approach is also there. Shouldn't, should have done that. Should have thought of it. Well, fine. I'll take a 10 minutes of break, and after that, when I'll come back, I'll solve this question with one pass iteratively. Because one pass can be used recursively, but that'll take space. So iteratively will not take extra space in one pass. So be back in 10 minutes. Don't go anywhere. See ya. back. Let's go. So remove the nth node from end of the list. So 0, 1 and 2, and that's my pointer starts. So I'll take a list node of nth pointer. uh, this will be nothing but my start pointer. Start pointer will point to head, and I need one more pointer which is previous or end distance pointer, which will be null, pointing to null. Now there will be a counter which will start. Now while start is not equals to null, I need to stop at the last node. So while start, and also start next is not equals to null. So I need to remove the last pointer. If start is equals to start next and count plus plus. Now what I want is, if count is greater than or equals to n, if count reaches to n, my n distant pointer will start. N distant pointer will start from head. And if n distant pointer is there, then n, sorry, I can add n distant pointer. If it is there, if it is not null, then n distance is equals to n distance next. So this will stop. So if so what I need to do, start will be at that point, and end distant will be start will go here and distant will go here. So I need to remove end distant. So if n distant next is there, and distance, we are removing that, right? So, and distant next will be equal to and distance next next, and return head. So if there is only one node, and I have to remove that node. So if there is one node, so if n is equals to no, not n. So start is head, start का next is है. What I'll do is, and distance will be null in that case. If I increase my count, so this will do what? This will place my end distant over here, over that position. Now I need a previous also. List node asterisk previous will also be null. Previous is equals to and distance. Now if there is previous, so if there is previous, so previous का next is equals to end distance का next. If there is no previous, and this is the node, first node that we need to remove. Else return. What happened? So 1 and 2. Initially my start is at head. So this is just one pass. Okay, so this got accepted. Let me check the editorial. How short? Okay, I'll be back in a minute. Just give me a minute. I want to fill my bottle. Okay, I'm back. I'm back. I'm back. Okay, so where were we? Spiral matrix, remove, done. Longest common prefix, container with most without repeating character, add to string. Okay. Okay, this question, this is a normal question, but this can be solved using, should I say, try. So I must have solved it using try. No, is it? No, not not try. Oh my god. Okay, so no try. But this can be easily solved with try. Just need to create a prefix try, because the follow up can be something like this. The strings, the strs are coming every time. You need to add it to your string and check. So instead of checking, iterating over whole, we can add it to our try. Just iterate over try once. So try will reduce the time complexity a lot. A lot means a lot. So a try solution is way better than anything. So this is just a horizontal scanning, divide and conquer. This is a binary search. Yeah, here comes the prefix try. So this is a try solution. I'm not going to code it out because I've already tried try. Let's just create a class for try, just in order to revise. Okay. So I have a class try node. I have a class try. There will be two things: integer, not try children of size 26, and integer isn't. Bool isn't or integer isn't. Yes, maybe. Bool isn't. I'll have a try constructor which will initialize this children as null, and also set isNt to false, and a semicolon. So we have this try structure which we can follow. So I can use this try. I can create a try node. Let me see if everything is correct or not. Try of okay. Bracket missing. Right. So this is my try. I can insert in this try all the strings that are coming one by one. So try solution can also be uh, very easy, but it's just try to implement try. We need some time, but rest of that thing is easy. Container most water is simply a two pointer approach. I would say uh, going from one pointer to another, and whosoever is the smaller one, I'll move that pointer, and at every time I'll find the height. It's just a very trivial solution. If any of the characters frequency increases from 1, I'll just subtract it until and unless we that frequency is reduced, and we find the length and we move the pointer. So repeating character is fine. Adding two integer. This is something they will say not to use. So Google asked this 12 times. There must be some follow up to this. There must be some follow up to this. At least we should be able to know. We should know how without using plus operator how to add two numbers. So we are given two numbers, that is 14 and 3. I need to add these numbers. What does addition do? What's the bit of addition? 14 in bitwise count, I would say 8 plus 2. 8 plus 4, 12, 13, 14, 4, 2, 0, 2, 4, 8. So this is 14. And what's 3? 1, 1, 0, 0. So 0 plus 1 is 0. Okay. 0, 1 is 1. 1, 0 is 1. 1, 1 is 0. Carried 1. Carry 1. 0, 0 is 0. Now we have 1, 1. Carry with 1. Give me 1 and carry 1. We have 0, 1, carry 1. 0, 1 with carry 1 is something 1, 1. 0 and carry. So somehow it will fall somewhere here, these conditions only. So 0, 1, 1, 1, 1, 0, 1 here, 1, 1, 0, 1 here, 1, 1, 0, 1 here. 1, 2, 4, 8, 16, 16 plus 1, that is 17. Oh my god, what is this brute force? What? They're solving it using Dijkstra algorithm? My goodness. Floyd Marshall. prefix sum, suffix sum, segment tree, range sum query. What the hell is this, man? Binary index tree, Fenwick tree, range sum query, bit manipulation. Here comes the bit manipulation. This is what I want. If nums is 0 0, sum XOR nums 1 XOR nums 2, nums 1 and nums 2 left shifted ones. What does that mean? Zero zero one one. So XOR is 1011. Sorry. Yeah, 101 110 101 1101. It's 13. And this is and left shifted ones, which is nothing but 0010. Evaluate of string expression. carry. This is the bit manipulation approach. I'd say I should solve this in using bit manipulation instead of doing all those things. So while num2 is not equals to 0, I'll do what? Num1 is equals to num1 XOR with num2. Num2, I would say carry, will be num1 and with num2, and num2 will be equal to carry left shifted once, because carry will be added to the previous one, and return num1. Sorry, integer carry. Oh sorry, I need to keep the carry in a separate variable because num1 changed. Intersection of two sorted arrays. So string can be large enough, can be anything. So I need to find the largest string, largest odd value in. Okay, as a string. If it would have not been as a string and a 32-bit integer, as a follow-up question, what would have, what I would have done from not from last. It doesn't matter if we are taking any last or first. This is fine. This is also easy. Range module is some a question that I solved it twice. I'll go through it once. Adding a range, I'll find the upper bound of its left, while its right is greater than IT of first. That means it is colliding with this. So I'll find right maximum IT and erase this range. Now one left is the previous one. So it is, if it is not in at beginning, I'll check its previous second value. If the left value is smaller than or equals to previous second value, adding a range, that means I'll again take the maximum to it, or I'll simply add maximum to that, or if not, then I'll create a new range. So this is add range. Add range is fine. Now remove range. I'll have a cut end. Always I'll have a cut end. I'll check that cut end if working or not. So just for example, we have 2, 5, 7, 8, 12, 22, and I need and there is a range. Maybe let's take this as 10. From 9 to 21, cut 20. From 9 to 20, remove range. So what I'll do, I'll take the upper bound of this. Let's take 4 from 4. From 4. So I'll take a upper bound for this. We'll reach to 7. Now until and unless I'll find the cut end. Cut end is cut end or maximum max R of right second. This or my cut end. Cut end is nothing but 0 initially, or even a lesser than -1. Anything will work. So maximum it will be updated to 10. Now this 12 is also lesser than this right. So again my cut end will increase to 22. Now it reached to end. I'll remove this. Now there is a left value which is previous. I'll check this if there is beginning. What I'll do is I'll check with this 4 is colliding with this. So what I'll do, I'll update this value as 4 and I'll find the maximum. And if my cut end is more than my right, that means there was some value from 20 to 22 left. So I'll add that value 20 to 22. So this was range module, and query range is very simple. Find the upper bound of left, and if it's right, is at the beginning, then return false. Else its previous second is greater than or equals to right, return true. Else false. Excuse me. This can be solved using a hash map. There is no editorial for more than this. To set one dictionary, one map. It's done. I'll try to complete this and then I'll stop. So number of island, merge interval, maximum subarray, palindrome number, create hello function is a SQL merge sorted array, and this, and then do some. So number of island, I need to check how many number of islands are there. So if we encounter a 1, I'll call a DFS and make everything to 0. Simple. Merge intervals is very simple. It was meeting rooms 2. No, yeah, 2. We'll have a start and end. We'll sort it based on the beginning. We'll have start and merge interval. We'll push it in my queue. Fine. Maximum subarray sum. Whenever a value is reduced, I'll take this value or this plus this. Whosoever is maximum, I'll take that one as current max. So if nums of I is greater than, so then nums of I or see this plus this. So and global max. Palindrome number. Reverse a number. If it is lesser than 1, lesser than 0, obviously return false. Then reverse a number, and if current number is equal to that number, if lesser than 0, else, oh my god, I used a lot of if else at that time. This must be 2021. Correct. This is also, I'll start from this position, and this position, 3 pointers, and I'll move whosoever is bigger, I'll place it over here and I'll move. So this was a very good question. So everything starts I can select a sub array, and so 1 2 3 2 1. This is something 1 1 and 2, 1 2 and 3, 1 and 2, 1. So what I can see, how many I can see. So 1 plus this minus this is 1, plus this minus this is 1, plus this minus this is 0 0, so it's 3. It's from left. You are checking the height. Let me try with 3 1 5 4 and 2. So 3 1 2 and 3, 1 1 2 3 4. Sorry for this drawing, such a bad drawing. 1 2 3 4 1 and 2. So we can see 1, 2, 3 from this side, then 1, 2, 3, 4 from this side, 4 plus 3, and nothing else. That is 7. 7 will be returned. So this is how it goes. And now 2 sum is like one of the easiest problem, I would say. So we have an ordered map. We check from target minus norms of I whether it is present or not. If not, we'll push it corresponding to index. If it is there, I'll return that value corresponding to that index. Done. Okay, so 30 days done. Only one question is left. That is just kth smallest in lexicographical order. I'll do it this week. And then we can say that it's completed for 30 days. We'll move for 3 months. I have already completed many of the questions from 3 months also. I'll try to complete more. I'll try to solve more questions. So yeah, okay. So what I targeted today, I completed it mostly. So what I will do is now I'll take some rest. I'll eat something. I'll take some rest, enjoy, and then after 1 or 2 hours I'll come back again and I'll try to solve this that question which is left for 30 days, which is kth smallest in lexicographical order. I'll try to solve this question. Let's see what goes out. And yeah, I think that is it for today. I thought of going for one more sessions, but I don't feel right now. I need some break. So after this I'll be doing it after taking some breaks. So thank you guys for being with me, for watching the stream. I hope you enjoyed it. We'll meet again most probably next Saturday, or if possible tomorrow also. I'll see to it. If possible, I'll try to stream for some few hours tomorrow also, and we are good to go. So okay, so I'll be stopping the stream here. We'll see you soon tomorrow or next week. Till then, have a great day, have a nice day, have a great weekend. Bye bye after it completes. Okay, bye bye. Bye.